Okay, in this video, I'm trying to give an example about how to use the tracer and the task system. And in particular, we're going to implement a tracer that can report the number of instructions that is executed in the whole simulation. And we're also going to extend this tracer so that we can specify the number of instructions that we want to execute in one instruction so that we can terminate the simulation when the number of instruction is hit. So let's start from my browser. I'm going to share my screen. I'm going to share my browser screen here. So this is the issue panel of MGPUSim, and we can see there are a list of issues. There are many of them are feature report, and there are few of them are considered as bugs. So let's find this particular issue that we want to solve. It is an instruction counter and stopper issue, and it has a feature request label. So we want to start solving this problem by clicking on create a merge request. Clicking this button, it will create a branch for us, and it will also create a merge request for us. Now we can come to our terminal. In our terminal, we can go to the MGPUSim folder. In my particular system, I'm storing it in the folder called in my home folder. It's called dev.src gitlab.com Akita MGPUSim. And in this folder, we first check we want to start from our master branch. Its status, we are currently in the master branch and we want to have the most recent version of the master branch. So we can run a git pull to update it. And there's some updates that is recently merged into master. And you can also see that the information about this new branch, which is called 254 instruction counter and stopper, is pulled from from GitLab. Then we can clone, we can check out to that branch, which is called git checkout 254, and we can use tab to auto-complete it. It's instruction counter and stopper branch. Then we start to implement this instruction counter and stopper. Let's use Golang to implement it. Let's start Golang. Okay, so we're going to start work on this particular tracer. Let's implement in the CU, in the timing CU package, because we are going to calculate the trace. Okay, so we're going to implement this tracer. Let's implement this tracer in the runner folder, which is in samples runner. Let's start a new file called inst tracer. Now go. It automatically creates this package declaration called runner because it's in the runner folder. And here we want to define a struct called type inst tracer. Inst tracer then struct. Now we can have a count which has the type of uint64, so that we hope we can get we can support more instructions. So we can have a definition, say inst tracer can trace the number of instruction completed. Then we can implement the tracer interface. We can implement the tracer interface so that we can generate a code, implement method, and here what we're going to implement is tracing dot tracer. Yeah, Golang can help us find it. So tracer. So let's say, okay, let's name this variable, receiver variable as t, and in tracer, let's use the pointer version of it, and let's name this variable called task, which is good. Good. Then all of them are set as panic implement me. So here we want to increment this count when we complete one instruction. So here we need to collect the information about the starting point of a particular instruction. So we can define a variable called inflight inst. We can map, we can set it as the type of map string task. We can map from a string to a task, which is tracing.task. So when we start a task, we need to check what the type of the task is. So we can come to the compute unit, timing compute unit package and see what is the exact type that we have defined for this instruction tasks. When we come to this compute unit, then we can find this particular function. I don't know why there are so many arrows. It seems like a problem with the Golang, not really a problem with the with more code. So here there's a function called log inst task, and here it starts this task with this type of information. The thing where we are interested in is this kind field called inst. So we only care about this kind of tasks. So here we can have a filter, say if task dot kind is does not equals to inst. You can match if this is inst, and here is also inst. It's a perfect match. Now, if it's not inst, we simply do not care about it. We want to exit directly, so we can simply return. Otherwise, we want to store this information in the in-flight instruction map. So we can call t.inflightInst task.id, which equals to task. Here, this task is task. Okay, it's okay. We can change this variable to tracing.task. Then for step task, we simply do not do anything. Do nothing. We don't want to keep the information about the task steps. And finally, when we complete the task, we need to check if this task is in the in-flight task. Is in the in-flight instruction map. Because if you come back here, you look at the code, when we end the task, we only care about ID, the time, and where it happens. We do not really care about the kind. So we cannot use the end task, this function call, to determine which type or what the kind of the task. So here we can first check if this task is in or in-flight instruction or not. So then let's check if found underscore found task t.inflightInst bracket task.id. If not found, we simply do not do anything. We do not care about this particular task. We can simply return. Then if we find it, we can safely delete it. Delete t.inflight instruction task.id. Then we can increment the count plus plus. Sorry, t.count plus plus. So then we have a task counter implemented. Then we need to attach this task counter to all the compute unit. How we can do that? Let's go to this runner. So in the runner, we set a set of metrics, and we want to add this information as a flag, so that if this flag is set, we want to report the number of instructions executed. Let's come to see some other examples. Cache latency report flag. Let's add another flag right above it. Let's call it var inst count report flag, which equals flag dot bool report inst count. By default, it is false. Then the comment or the help information is report the number of instructions executed in each compute unit. So we have this flag set. And also one thing we need to remember is that there's a report all flag. So if this report all flag is set, this inst count report flag needs to be also automatically set to true. So here we can see, we can search for, let's see here. Okay, if this flag is set, and then we set this particular variable in the runner. So we need a variable for it. Let's call it report inst count, which is type bool. Then if this particular flag is set, if star inst count report flag, then we set this particular variable to true. r.report inst count equals to true. Let's see. Okay, we're checking this report all flag. If it's true, we're also reporting inst count equals to true. So we can find an example how we attach a tracer. Let's say cache latency tracer. Let's say cache latency tracer. If we're not reporting cache latency, then we simply can return. We do not really attach this tracer to any real component. And say if we want to report this cache latency, then we're adding this tracer. We're creating this tracer. In particular here, we want to, okay, here's the tracer. We want to create this tracer as the type of new average time tracer, so that we can trace it. Internally there's a filtering function, and we want to create this tracer struct, which combines this tracer and the cache it is tracing. Then we can call this tracing.collectTrace to attach this tracer to the cache. So similarly, we want to create this type of structure to bind a tracer to a particular component. Let's come here to see one example. Here we have this example called cache latency tracer. What we want to do is type cache latency. We don't want to call it cache latency tracer. We want to call it inst count tracer struct. Then we need a tracer. Its type is should be inst tracer. Then we also need to combine a compute unit. We can simply use Akita.component. So this is an inst counter, inst count tracer. Then here we can add this one. Here, let's create this variable called r.add inst count tracer. Okay, let's find this kernel time tracer. We can add it below the kernel time tracer. Kernel time tracer is the most important tracer here. Let's find this add cache latency tracer, and we insert this function here, r runner add inst count tracer. Then still, if we're not tracing it, simply return r.report inst count, simply return. Otherwise, let's traverse through all the GPUs. For GPU range r.gpu driver.gpus. Then we need to traverse through all the compute unit. CU in range GPU.CUs. Let me check what's the type of CU. I think it's just a component. Yes. Then let's create this tracer. Okay, tracer. Let's instantiate this tracer, which has the type of inst tracer. We don't need to instantiate any field. The count will be set to 0 at the beginning by default. Then we can append this tracer to the cache latency tracers, but here we need an instruction inst count tracer. So r.inst count tracer append. Of course, it's not there. That's added. Come up to the structure definition. Here we have cache latency tracer. Then we have inst count tracer. Inst count tracer. And we can come back down here to finish this append function. r.inst count tracer, then with tracer. Not really a tracer, but we need to create this inst count tracer and fill our fields. The tracer is the tracer we have just created, and the CU is the CU where we will attach to. So recalling inst count tracers. Inst count tracers. Yeah, it's a list, so it needs a plural form. Inst count tracers. Come back here, let's attach this tracer. So we can call this function tracing.collect trace. So we're going to collect trace from this CU to using this tracer. Here the CU is not fully working because we need a type conversion. We convert it to a named hookable, tracing named hookable interface. Okay, because only named hookable interface can attach a tracer, and CU it is a named hookable type. So we need to make this type cast. Then we have this tracer configured properly. Then the next task is to print the collected metric at the end of the simulation. Now we can check this metrics.go function. Now we can let's see how we can use this collector and the dump function. So there's a function called report stats. Let's add another function called report inst count. Then the function r runner report inst count. In this function, we inst count is capital C, and we can collect this message using the matrix collector. So r.matrix collector.collect, where it is happening is we first need a loop to loop through the tracer, the instacount tracers. So t range r dot inst count tracers. Then it collects from the particular position that is called t.cu.name. It has a name, and then let's see what's the second field of collect is called what. Here, or what is called instacount, and the number is, let's change it to float64, because the metric selector always collect a float64 number, although we're sure instacount is an integer. But here we can say, we can use this t.tracer.count. This is the number of instruction that is executed. Then we have collected this information, and it's called in this report stats. So I think by far we have completed this task. So let's go to the terminal and try to execute a very simple program and see if we can see the statistic report. Let's go to samples, go to FAR, then let's compile it with Go build. And let's run FAR, length equals to, say, let's make it short, 4K, with timing, with report all. Okay, there's an arrow. I kind of know what the arrow it is. In inst tracer, we need to initialize this map. So we need to create a new function as a constructor. Func new inst tracer, which returns an inst tracer. T equals to inst tracer. We're creating this inst tracer and return T. And here we're going to create this in-flight inst, which is a map. Okay. We can do this. I think I can also actually do make a map, but they should be equivalent. Here it should be a star. New inst tracer. Again, comment say new inst tracer create a tracer that can count number of instructions. So one thing here I actually want to do altogether is to change this particular variable to a private variable. We don't want to publish it. So let's use this refactoring tool, and let's change it to inst tracer. Okay, then Golang can automatically do it for us. Let's do refactor. Okay, change to inst tracer, and still we don't want to publish this new inst tracer constructor. So let's also change it to a lowercase, and let's do the refactor. And you can see in the runner, it should automatically change to a lowercase. Here, yeah, it's changed to a lowercase. Okay, so we can go to the, we can go build, and let's try to run it again. See, okay, I know we need to use this new function, new inst tracer, to use this function. Otherwise, the map is still not initialized. Let's go build again. Thankfully, it is very fast. Then we can run FAR. Then it runs to the end. You see in the report, there's a matrix CSV file. We can use new Vim to open it and see, let's say, inst count. Okay, we can see this inst count information. And in this shader array 00, CU00, this particular this particular compute unit, we have executed 1,568 instructions, and all the compute units execute the same number of instructions except for the compute unit that has no task to run. Okay, this is we're partially done with this task, so we can say we can commit the code. The status git add -- all. We know there's only one file. Git commit add an instruction tracer. Git push. We can push the code to GitLab so that GitLab can run the test for us. Okay, the next goal is is that we're going to stop the execution after the count reaches a certain level. So let's say we have a max count, max inst. Let's just call it max count. It's also type uint64. Then we can create a func new inst count, new inst stopper. Inst tracer is still with the type inst tracer. Say new inst stopper will stop the execution after a certain number of instructions. A given number of instructions is retired. Instructions. Now we need to pass in an argument called maxInst uint64 so that we can initialize it. We can even copy it and paste this part of code. But we need to set this maxInst to be max count equals to this maxInst. Okay, so in this function, in this endTask function, we add a count if we check, say, if this t.max count is greater than 0. If it's 0, we consider it is not limited. We can run to the simulation, to the end of the simulation. Otherwise, if it's greater than 0, then we're really using this particular field. And we should stop the instruction. If this max count is greater than 0 and t.count is greater or equal than t.max count, we should stop. How we can stop is we're using this @exit function, @exit library, and we're going to call it exit with code 0 because it's not an error we wanted to return at this time. So here, let's come back to this code, and here we're going to introduce another field that's directly put it here, call it the maxInst count flag uint64 maxInst. Default value is 0 because we don't want to set it. Then say terminate the simulation after the given number of instructions is retired. Then we need to implement it. Basically, what we need to do here is if this value is greater than 0, we need to create one tracer, one inst tracer, and attach this tracer to all the compute units of all the GPUs. Let's come here, then say inst count tracer. We're not going to do this. Then runner, we're going to add another field called inst maxInst stopper. Now it has the type of inst tracer. initiate add kernel tracer. Now what we need to do here is to say r.add kernel add max inst stopper. Add a function that we need to call this function. Let's add it right above this kernel time tracer. Func r runner add max inst stopper. Then say if r, not in r, but in that flag, max inst count equals to 0, then we do not do anything. We don't want to attach this stopper. Then if this is greater than 0, because it's an unsigned int, it's either 0 or greater than 0. If it's greater than 0, we can create this stopper, r.inst max inst stopper. We can create it as new inst stopper. What's the value? That is given by this max inst counter. Max inst count. Then we should attach this counter to all the compute unit. We can actually copy and paste this code. And copy and paste this code, but we're not going to insert into this tracer. We're going to simply apply this r.max inst stopper to all the compute unit. That's all the thing we need to do. Oh, here's a misspelling. Let's just change this variable here. Okay, solve the misspelling here. But we're completed with this max inst stopper. We can try to go build FIR and try to see if this field is there or not. Let's run .fir-h. We can actually see, okay, max inst is here. Then report inst count is also here. Okay, now we can run FIR to run all the same with the same argument, but at this max inst, let's run, say, how many instructions? Let's run 3,000 instructions, and just run it and see what's going on. See, the simulation is terminated without even finishing any work group. And let's remove this matrix and see if we can still see matrix or not. Let's run it, then ls. Okay, the matrix file is not generated. That's a problem. So this is initialized. We're adding a set of tracers. Then let's see when this tracer dump is executed. Okay, run, and at the end we report stats. This is not acceptable because when we run this, say, GPU driver terminate, when we run, I think when this GPU driver, the benchmark run, then we terminate at some time. This function is already, this simulation is already terminated, so it won't actually reach this point. So what we can do is we can change this function, and we register this function with the @exit library so that it can be called when this @exit is executed. So we're going to comment it out first. Then let's come back to the initialize part. Okay, so we're going to register it at exit.register. Register, we can actually directly call a function, which is r.report stats. Okay, now we can try to execute this program again. Go build, then fr. Hopefully this matrix file is here. Now we can see let's use nv matrix.csv. Let's see. Okay, this the number of instructions is collected here. You can see different CUs executed different number of instructions. There's some randomness here. Now we can see the driver total time is this total time. Then the GPU kernel time is not showing up because the kernel is not completed. This is a problem. We can think about how to solve it. Now we can also see the number of read heat and read miss, but here you just need to be careful that if this, say this transaction is not completed, it's not really calculated in this level here. At least it's not calculated in this request average latency. But still, we can get most of the metrics from this file. The only thing we cannot get is the kernel time because the kernel is not completed and we returned it early. Okay, so at this moment where we have completed our task, we can run git status and git add all, git commit, add max inst stopper. Now we push to GitLab. GitLab will automatically run the test for us, and if it can run, see this one, this is probably our first commit, and it failed something. Go build or lint is failed. We need to solve this problem. I guess if there's a problem in the previous test, and then there's still problem here, so we can solve this problem. Let's come here, come back to MGPUSim. Let's run go build dot slash dot dot dot. Sorry, 3 dots. It's not showing any error. It's building perfectly. It should be fine, but it's reporting some error here. It's undefined. Did I commit that file with status? Jobs. Merge request. Instruction counter and stopper. Changes. Runner. We have this runner committed, but we haven't really committed that file. That's the problem. So git status. Let's go to runner. Samples runner. Git status. ls git add -f force inst tracer. Not sure why this file is not included. Okay, we're including this inst tracer. Hopefully it can run. At least it should pass the build test and the unit test. Let's come back to the overview. Hopefully it will run soon. Yeah, it started to run. Let's see this go build. It's a good sign that it is downloading these repositories, these dependencies. Okay, it can run. At least it can build. And it's gonna take a very long time to run this acceptance test. So I will stop the video here so that I hopefully after this video you know how to use a tracer and how to count put the number of a particular type of task in your simulation.